online, I would like you to show up once to sign up, okay? And the sign-up sheet is over there. You can attend all the lectures live. There are 3 of us, as I mentioned yesterday, Steve Lyons, Simone Belmar, and myself. And we have 3 different modules, and so you can take almost all of it. You'll only get 24 of the 36 lectures if you come to the live lectures between now and they should finish up by March 15th or thereabouts. You'll have to take another 12 lectures online, and there's a whole list. In fact, that's what this is. If you go to my website, eager.mit.edu, and you go to classes, it will list this class, and it will, the current lecture videos, I guess there is a link here. I don't know if it's up for everything, but I haven't clicked on that link, but it says spring of 2018, that's now. If you go down, you'll get all the past lecture modules, and you can design your own course. But this stuff is all online stuff. You also, if you miss class, we will videotape each of the classes that are live, and so if you miss a class, you'll be able to catch up that way, okay? And, you know, it's up to you. Since there are no quizzes, you can do whatever you like, but I would encourage you, since there's not much to this class except coming to class or watching the video, that you actually make up the classes if you miss some. I like to think it would be more coherent if you did that. The other thing is there should be, I didn't do half of my presentation from yesterday because it basically talks about my teaching philosophy, and the PowerPoint is on Stellar. So you can go through some of this, or if you want to watch it live, it's basically the same stuff as I taught the last 3 semesters. It should be there on an intro. Brian, we might want to have Neil create an intro topic, okay? Just like the other modules, but it'd only be 1 lecture. But it talks about teaching philosophy and teaching secrets. One important teaching secret is, why would someone spend an entire lecture doing a derivation on the board? You've all been in an engineering class or a science class, and they solve some 4th order partial differential equation or something, and they screw it up all the time. Why would they do that? Well, the simple answer is they didn't have time to prepare a lecture, okay? And anyway, if you watch the video, I'll explain how I learned that. And there's things about how to make presentations. There are some articles to read. I suggest you read this, Why Did the World Trade Center Collapse? Not because I wrote it, but I did. And for 9 years, I was #1. If you looked up WTC collapse on the internet, you would find this paper was #1. And the reason was I wrote it simply. And so this is sort of, I think, an example of how I would like you to write your papers. It's also quantitative. I put real numbers in there, okay? And I've also become the brunt of all the conspiracy theorists in the world about the World Trade Center. Okay, they've had websites out against me and they've written to the president of MIT saying I should lose my tenure because I'm a shill for the government. I'm just trying to make America great again. I mean, gee whiz. Anyway, so I talk about things like how to communicate. I learned to communicate a lot from Lester Thoreau. And so there's some stories in there about Lester Thoreau. He was dean of the Sloan School back in the 80s, so far as that goes. But we don't have to go through this. See, there you go. This is an old slide from a year ago. If you remember, November a year ago, these 2 people were running for president. And slogans without content are not communications. Oh, sorry. That's what politics is all about. So anyway, if I can figure out how to find my cursor, that's that. And so today we're going to do what is total quality management. Does anyone have any questions before we begin? Has everyone gotten the sign-in sheet? If not, okay, fine. So total quality management, I decided to do this. I actually 25 or 30 years ago was co-director of what we called the Leaders for Manufacturing program, which is now the LGO program in the Sloan School. And it was kind of through that I learned about total quality management. And I remember back around 1997 or so, I was department head, and I asked a group of undergraduates in the department if anyone knew what total quality management was, and the first answer was someone in the back of the room says, "It's bullshit." Okay? And I said, well, you know, you're probably right about a lot of that, but the CEOs of some of the top companies in the country have given a challenge to universities to learn what total quality management is, because they are using it in their companies and we're not teaching it at the universities. So it turns out there is some good to total quality management. There's also a lot that's just exactly what the student said. It's bullshit. If you go to a book that was commissioned by the Center for Quality Management, this was a group of 10 CEOs or executives in the Boston area and 3 MIT faculty, and I'll talk about that later a little bit. But they wrote this book in 1993, and in this book it says total quality management focuses on customers, focuses on continuous improvement, total participation, and societal networking. Well, in fact, if you look up other terms for or definitions of total quality management, you're going to find there's as many different TQMs out there as there are people who teach it. But there are, or have become over the last quarter century, a number of common themes. Okay? And some of them are quite useful. We're going to look at some of these and see about what their history was, where they came from, and you're going to find that a lot of these things are not really new. And I was thinking about it this morning, and I'll explain in a little bit why we have all these terms that are sort of synonymous, but everybody's got a different version of it. And I'll go through that. So this book, A New American TQM, and I'll pass it around if you want to flip through it as I'm talking. I say it's worth skimming, so some of you can do your homework right here in class. You can skim it. Professor Shiba was from Tohoku University. They brought him over. He wrote the book. I took the class as one of the MIT faculty who were encouraged in the manufacturing program to take his class on TQM. It was published by the Productivity Press, which was established in '89 by 10, as I said, 10 area executives and 3 MIT faculty. One of the foreword's written by Ray Stata. Anybody know who Ray Stata is other than the former Analog Devices chairman, founder? You ever seen the Stata Center in electrical engineering? He gave it the first $25 million. Anyway, and Tom Lee, who had been a faculty member at MIT, and I'll talk a little bit more. In the book, there's actually a number of useful things. In the very first chapter, it talks about originally we used to manufacture as fitness to a standard. And then it became fitness to use, and then fitness to cost. And then there was this thing that was coming out in the 1980s called fitness for latent requirements. And the example was something that most of you have never heard of, the Walkman. Have you ever heard of the Walkman? What was the Walkman?
One of the first portable music playing devices?
Yeah. It was about the size of, it was bigger than a deck of cards, but it basically had a cassette, and the cassette you could play your music, okay? You didn't have digital music at the time, okay? But Sony came out with the Walkman, and no one knew they had to listen to music while they were walking. That was a latent requirement, but Sony made a fortune off these things. They cost about $100, and everybody had one, and they came in all kinds of colors. It's just like your music players now, except it wasn't digital. Does anyone know what the breakthrough in technology that allowed the Walkman to flourish? It was neodymium iron boron magnets. Okay? They could have made Walkman in the 1970s, but you had to use the battery power to create a magnetic field to run the little motors. But when General Motors developed neodymium iron boron magnets in the early 80s, they could downsize the size of the starter motor, and all the other motors in your car could be 1/3 the volume and use 1/10 the power, because you were getting your magnetic field from the permanent magnet, not from an electric current. So all of a sudden, your Walkman wouldn't have a battery life of 5 minutes. You could have a Walkman that had a battery life of 2 or 3 hours, which people thought was great. How many of you would be happy with 2 or 3 hours on a cell phone now, right? And you want your Walkman also to read your email, give you email and all these other functions. So, but that was one of the things. This was fitness for a latent requirement, fulfilling requirements that people didn't even know they had. Okay? You could go jogging and listen to your music at the same time. That was a big deal back then. Well, Tom Lee was an interesting person. And turns out in 1990, I became a director of a center at MIT, and Tom Lee's office was just right in the first floor of Building 10, and I was around the corner. And we knew we would meet each other at the restroom from time to time, and we knew each other. He was a wonderful person. His CV, I don't know if he was originally an MIT student or not, but in 1990, he was a former vice president of General Electric switchgear division down in Philadelphia. When he retired from General Electric, he became a professor of the practice in the MIT Lab for Electromagnetic and Electronic Systems, which is basement and first floor of Building 10. Then, about a year later, in the late 1980s, he was asked to be the chairman of the International Atomic Energy Commission. So he could go to Iran and say, quit building those nuclear bombs. Okay? And then when he came back from 3 years at the IAEC, he became the acting director of LEES about 1990. I think it was in the same Tech Talk announcement that I became director of one center and he became director of another center. So we saw each other in the hallway, and he was congratulating me on, because I was just a 40-year-old pup. And he was this 70-some-year-old distinguished scientist, engineer. He was also a member of the National Academy of Engineering and other things. And he was congratulating me. I said, well, congratulations. What do you think about being a manager at MIT? How does that compare? And his answer was, at GE, I had no real authority, but everyone treated me as if I did. Okay? You really can't force people in a company to do what you want. You really have to kind of do it by consensus. And you can order them around, but if you do that very much, if you use your authority, you lose your authority, is what I say. At the IAEC, I had absolute authority and everyone knew it. At MIT, I have no authority and everyone knows it. Okay, so that's what managing at a university is all about. Herding cats, as they call it. Okay. So the TQM challenge was something where these 6 companies, half a dozen Fortune 500 companies, challenged half a dozen elite universities to send 50 of their faculty back for a week to learn about TQM. It turns out at MIT there were 75 faculty that signed up. I don't think you can ever get 75 faculty to agree on anything today, okay, or before that. But 75 of us went to the IBM Executive Training Facility on the Hudson. And you might have stayed at a Four Seasons hotel, but you haven't stayed at a nice facility until you stay at the IBM Executive Training Facility. Okay? I didn't know what to expect, and I drove in, got in late one Sunday night, hadn't eaten dinner, and I thought they were going to send me out to some McDonald's or something. And said, oh no, the cafeteria is still open. It's like 10 o'clock at night. And you should have seen this buffet. I mean, it was fantastic. And I'm sitting there thinking, well, they must have had some convention here today. No, it was for us, okay? And it was just, everyone had their own motel room, basically. And we got in the next morning, we got together, and it turns out Chuck Vest, who was president of MIT, had come to welcome us and encourage us to learn from industry and find out what they're doing on total quality management. And then a senior executive vice president, which I think when you get a couple of modifiers to the term vice president, it means you're higher up, okay? And you got two of them, means you're even higher up. And anyway, that was the guy, the person, whoever he was. He welcomed us to learn about customer-driven quality, okay? IBM didn't want to use TQM because other people used that, and IBM was special, okay? So they had their own name. They called it customer-driven quality. And he explained how they had 380,000 employees 10 years before that, and they had eliminated 90,000 of them without eliminating any of their hourly workers who actually did the work, okay, of building products. You got to remember, this is back when IBM made Selectric typewriters and mainframe computers and things that don't exist much anymore. Anyway, and he told us how they'd been top-heavy with management to prevent problems from rising to the top. So they had about half their employees were salaried executives, and they eliminated roughly half of those. And so I was sort of dumb and naive. I raised my hand after he asked for questions. I was the sixth or seventh person. I said, well, now that you've eliminated half of your salaried staff, are you seeing more problems rising to the surface? And he stopped and he thought and he says, no, I think we're seeing fewer. Okay, so what I learned that day was you can have 25% of your workforce, and in fact, 50% probably of your salary, okay, that you give to workers, because these are the higher paid people, doing nothing. Actually, they're doing worse than nothing. They're doing negative value added. They are creating problems rising to the top. Okay? So part of what is exciting about TQM is some companies learned they can do without 25% of the workforce and then do a better job at the same time. Okay? That's why CEOs get excited about it. That's one of the reasons. So there are some things that might be worth reading. Okay? This is a book, which again I'll pass around. I say sort of worth reading. I've quoted from it in some of these notes and stuff. And by the way, this PowerPoint, like the one yesterday, will be on Stellar, and so you can get to that. This is a 1985 book. The one I'm passing around is a 91 edition. And they give a short history of total quality control. The short history, which is the first chapter, goes back to the 1920s. And that will be on Stellar. It's fair for me. Steve Lyons will explain to you why. Fair use at the university means I can copy that 10 pages and give it to you. Not give it to you, but... As
long as it's used for educational purposes.
Right. So if anyone asks you whether you learned anything when you read it, say yes. Okay? And I won't go to jail. So it's available on Stellar, and it'll give you a brief review. It goes back to Schuhart. And we're going to talk later about one of the methods is the Schuhart chart. Anyone ever worked in industry? You ever heard of a run chart or a control chart? First invented by Dr. Schuhart at AT&T Bell Labs in 1923 in a memo. Okay? So TQM's not exactly brand new. In fact, we're going to find a lot of things that are part of TQM are just things that people have kind of renamed. And why is that? Well, most of TQM, it has the M word in it, the management word, and so therefore it belongs to the business schools. Now, Steve, as a Sloan grad, I want you to cover your ears on this. In the School of Engineering or Science, you get your tenure by writing individual research papers, right? And I actually have 4 volumes, which are my research papers over the years, and I haven't put the 5th volume together because I'm too lazy, and no one cares anyway. Just get thrown away when I die. Anyway, actually it could go to the MIT archives, and they will put it in a basement somewhere. And actually, they probably won't. They'll probably just put everything in digital form nowadays. But I have never written a book because I don't have time. I'm too busy writing papers. But if you're in the School of Humanities or the School of Management, you get your tenure by writing a book and becoming famous for that book. Anybody think of a famous management book? Oops, sorry. No one knows a famous management book? What's the most famous one to come out of Harvard Business School for the last 25 years? The Innovator's Dilemma? Clayton Christensen? Boy, if you mentioned that 15 years ago in Washington, everybody thought you were God. If you knew about disruptive technology. Have you heard the term disruptive technology? Okay, that's Clayton's term. Okay, I've known Clayton since he was a graduate student. In fact, my daughter worked on part of the book. And you'll find me referenced in the book because my daughter came home one day. She was working one summer doing some research for Clayton on his book. And she said, "Dad, what's it cost to build a steel mill?" I've looked all over and I have not been able to find any number that tells you how much it costs to build a steel mill. Because Clayton has 3 examples, and one of them is the steel industry. I can't remember, one of them's the computer industry, and I think the other one might be healthcare. But he talked about disruptive technologies. And I said, "Well, Rebecca, I got a slide I put together." I was sitting in the airport with one of my graduate students in Saginaw, Michigan one day. The plane was late. And so I scratched this slide out that had the cost of building steel mills, integrated steel mills, and mini mills, and micro mills, and how things had changed. And if you take my selection of materials lecture, I'll tell more of the story. But basically, I said, I'll bring you the slide, copy of the slide. It's just one PowerPoint slide. It didn't have a lot of content, not too much more than this, but it had some numbers. I'd estimated, sitting there in the Saginaw, Michigan airport, waiting for a plane, that it cost $15 billion to build an integrated steel plant. Okay? I actually had a basis for saying that. The last integrated steel mill ever built by a company rather than a country was Bethlehem Steel Burns Harbor, Indiana plant from 1965 to 1971 or so. Cost Bethlehem Steel $5 billion to build that steel mill. That was in the late 70s, or late 60s. And Bethlehem, which was the second largest steel company in the world at the time after U.S. Steel, almost went bankrupt. And then they hired me in 74. That's not why they actually started doing better. In fact, they started going down after they hired me. But nonetheless, Bethlehem had invested $5 billion. Back in 1970, $5 billion was a lot of money. Okay? Today, it would be equivalent to someone wanting to, let's say, build a new semiconductor fab. What's a new semiconductor fab cost? Anybody know? Maybe 15 or 20 billion today. Or designing a new commercial airliner from scratch, 15 or 20 billion. And it turns out Boeing can do it, but just barely, only with a little help from the Air Force. And Airbus can do it with a lot of help from a lot of countries, okay? Well, it turns out no one else has built an integrated steel plant. No other company has built an integrated steel plant since Bethlehem Steel in the late 60s. We've built dozens of integrated steel plants since then, but they are all built by countries. They didn't have the backing of a measly little corporation that had $50 billion worth of sales. It was a whole country. I used to be the POSCO professor in the 1990s. In 1978, the premier of Korea went to, whose name I think was Park, and he went to Mr. Park, or actually it was Colonel Park, who was his chief of staff, and said, we want to build a steel mill in Korea so we can be rich like the Japanese, okay? And Colonel Park became, all of a sudden overnight, from being a military attaché, or whatever you want to call it, to head of this new steel company in Korea. By the time I had to go, was the POSCO professor, and had to go over there and give a talk, it was the world's largest steel company. They basically hooked up with U.S. Steel. U.S. Steel sold them the technology and built the world's largest steel company in Pohang, Korea. That's why it's POSCO. Except it's not the world's largest anymore. Anybody know the world's largest steel company today? It's Bao Steel, B-A-O. It's Chinese, okay? They make twice as much steel as the entire United States. And we were the big guys, okay? After World War II, we made 75% of the world's steel. Anybody can figure out why? Because we bombed out the competition, okay? A world war is a wonderful thing for rising to the top if they're not dropping bombs on your country, okay? You're looking askance, Steve.
No, I was just thinking about steel in China. I took a train in China one time, a high-speed train.
Right?
And it took us 20 minutes to pass the Bao China facility at 100 and whatever, 50 miles per hour. That's how big it is.
It's not small. And it's not one facility either. That's one of multiple facilities. It turns out there's certain industries that cannot bite off these today $15 billion, $20 billion development costs. Aerospace, semiconductor, steel. A company can't do it because they could be like Bethlehem Steel and go nearly bankrupt, okay? Just like MIT almost went bankrupt when they built these buildings in 1917. You can't bite off too big a lump. It's much better to have the nation support you, right? And that's what's happened to the world steel industry. And people build steel mills not for economic reasons now. Actually, it is for economic reasons, not for business economic reasons. You cannot justify building a new steel mill based on business economics. We have a glut of steel mills. But if you want to be selling steel as opposed to buying steel, your country will have a steel mill whether there's a glut or not. And so anybody know what the tragedy of the commons is? The tragedy of the commons is this right-wing guy in was he Stanford or Berkeley? Anyway, California. So I guess I'm redundant. I repeat myself, as Mark Twain said. This guy talked about how everything reduces down to the lowest common denominator. So China builds a huge steel industry. They can't eat all the steel themselves. They want to export it. And so it goes off into the market, and the government's backing it, so they lower the prices. I haven't read about the unfair competition of Chinese steel since this morning's paper, the Boston Globe. It's in there on page 2, as I remember, okay, or the business section somewhere. So in any case, getting back to the lecture, total quality management. Oh, I was actually telling this story because of Clayton. So that's why Rebecca couldn't find some company that had invested, because these are countries that are investing and they don't want to publish that they had invested. It would be against the International Trade Organization guidelines for a country to give that much of a subsidy to a company. But they do all the time. Okay, whether it's building semiconductor fabs, Intel gets help various ways. Other people do, Taiwan Semiconductor, you name it. Countries are betting to get jobs and investing in these things. So anyway, if you look in Clayton's book, which made him the #1 professor at Harvard Business School, there's a little thing, Tom Eager, about referencing my cost. And I learned where this great piece of information came from. I knew what it cost in the late 1960s to build a steel mill, and I multiplied by 3 because this was 30 years later. So I figured inflation was a factor of 3 roughly. So I said 15 billion. And Rebecca quoted my slide. And now you know the research that went into it. Okay? I have another example from my own personal experience of one time in like 1980 or so, got my tenure in welding. And I decided, well, how many welders are there in the United States? And I thought of a way to estimate it. I know how many pounds of stick electrodes they made, and 70% of the welding back then was stick electrodes. And I knew how much someone could use in an hour, okay? And I could divide that number and get a total number of people, and I could estimate how many were full-time welders and how many might be part-time welders, and I came up with a number that there were 500,000 full-time welders in the United States and another 500,000 part-time welders, okay? And I said this at some conference. And about 10 years later, about 1990, they come out with another edition of the welding handbook, and I'm flipping through it, skimming it over to see what's in it. And there it says, Department of Labor Statistics, there are 1 million welders in the country. And I thought, oh, so I called up my friend at the American Welding Society. Hey, where'd you guys get this number? And I guess somewhere it had said, I said, where did the Bureau of Labor Statistics? Says this is an American Welding Society book, and they were referencing this number and referencing back to the Bureau of Labor Statistics. And he says, well, that's your number, Tom. I said, what? No, it's in the book, it's referenced. No one has a clue except me where it came from. Okay? It was a very simple estimate, very simple-minded. I mean, a high school student could have done this. But there is. The Bureau of Labor Statistics is referencing me. Steve, I didn't get any royalty on that. Well, we should talk. Anyway. There's a lot of facts out there that are actually of questionable origin, is the point. Anyway, something else that's worth reading, and this, I think it's probably online. Well, for me, it's free online, and I don't know if that's because I'm using an MIT computer and the Sloan School allows me to get this. But there's a 1994 article on TQM's challenge to management theory and practice. And it gives some of the history and whatnot. Anybody have any questions? Okay. Where did TQM really come from? Well, so far as I can tell, the TQM terminology sort of came out of the 1980s. But some things like the control charts, the Schuhart charts, and we'll get to them later in the semester, they came out of Bell Labs in the 1920s. Okay? If you go to Wikipedia, the source of all knowledge, okay, it will tell you that the revolution, the TQM manufacturing revolution, in fact, one of those books I passed around, it says, the red, white, and blue one basically says, a revolution in manufacturing, okay? Whether it's a revolution or not, this revolution has been going on for a couple of hundred years, as far as that goes. Most people, or Wikipedia says the revolution started in Japan, and if you were living in the 1980s, you would say it started in Japan because the Japanese were beating our socks off in manufacturing, okay? So much so that I remember sitting in a little engineering council meeting in the 1980s, and Jerry Wilson was the dean of engineering at MIT, and they were having a discussion. Kent Bowen had been assigned in 1984 to start a manufacturing program at MIT, which he finally got 4 years later. He had raised about $25 million, and they started the Leaders for Manufacturing program, which at Sloan is now the Leader for Global Operations. Okay, but they decided in that meeting I was in, kind of in the 1986 or 87, that they should commission a book, and a bunch of MIT faculty, the MIT Commission on Industrial Productivity, should write a book which they ended up calling Made in America. And I like to quote, the three authors were Michael Dertouzos, Richard Lester, who's now a provost, and Bob Solow, who's a Nobel laureate. He was a Nobel laureate at the time. I like to quote the first, page 1, introduction. to live well, a nation must produce well. Okay? And that's why China built biosteel. That's why Korea built Pohang steel. That's why people in, was it Kuwait or not Kuwait, Qatar or whatever built their own steel mill because they had all this natural gas. And one way to ship the natural gas is to turn it into steel. Okay? It's easier to ship steel than it is to ship gas. Anyway, where did TQM come from? Wikipedia article will say it started in Japan. The Japanese were beating our socks off. The Japanese had a plan. They actually have a Ministry of Trade and Industry that actually gives a strategic vision for the country in lots of different fields. And the Japanese were very hurt once when one of them in the 1950s, after we had devastated them in World War II, and Japan was a very poor country in the 1950s, and they asked John Foster Dulles or some Secretary of State of the United States when he's over there, Mr. Secretary, we need to get some revenue. What can we export to the United States? And whoever it was, I think it was John Foster Dulles, says, well, there's nothing you make that we would want. Okay, so sort of like the famous quote, there's nothing left to be invented. Okay, Steve will tell you about that. This is back in the 1870s. The head of the U.S. Patent Office says, we might as well shut down. There's nothing left to invent. Okay, everything's been invented. Well, it turns out the Japanese took that sort of personally, and they started improving things. They started out with steel mills, and then they went to shipbuilding, and then they went to automobiles. And we'll talk a little bit more about that, but the automobiles. But basically, when I spent my year in Japan in the mid-'80s, 75% of the Japanese economy was based on shipping automobiles to the United States. And in the early 1980s, Ronald Reagan decided he was going to have a Star Wars initiative. We were in the middle of the Cold War, and he was going to beat those Ruskies by building an international Star Wars missile defense and offensive threat and whatnot. And it was going to cost, I don't remember, $500 billion, which was a lot of money back then. Not so much today. But in any case, we didn't have the money. And so the Japanese were more than happy to loan us the money so that we could buy their Toyotas. Okay? Anybody know why World War II started? One of the reasons World War II started? The Japanese didn't have scrap steel. They didn't have a big industry. And one of the things we did in the late 1930s is we cut off all steel scrap shipments to Japan. We were trying to keep them. They had raped and killed 30 million people in China, okay? The Nanking stuff. And we were actually trying to, just like Chamberlain, appease them, okay? By the way, has anybody seen the Darkest Hour movie? It's very good. It's worth seeing, okay? It's where Churchill took over from Chamberlain. But in any case, getting back to Japan. Japan started out building steel mills in the 50s. They started building shipyards in the 60s. In the 70s, they started building automobiles. I remember a Honda Civic was a joke in 1975. You buy a Honda Civic and it would be rusty 12 months later. And it was literally a joke. People made jokes about Honda Civics. They don't do that today. But the Japanese, again, were so offended, or probably you might want to say contrite, maybe be a better word, that they decided they were going to make the car that would never rust. And that's the Honda Civic today. Okay? It's because we embarrassed them into doing it. But in any case, we won. We beat the Soviet Union economically because we bankrupted them. They wanted to keep up with Star Wars and they couldn't afford it. They weren't making anything the Japanese wanted, okay? Unless you want bullets. In any case, we won the Cold War. But we had this tremendous debt to Japan. And now I'll give you Tom Eager's lesson of economics. So the Japanese had close, I think it's like $1 trillion worth of American debt. Okay, and this is when we only had a gross national product of $1 trillion or something. What is it today? It's 10 or 15 trillion. I think it's 15 trillion is our gross national product. Anyway, maybe it was 2 or 3 trillion, but in the mid 80s. But in any case, they had all these dollars. They were accumulating dollars. And then they were loaning them to us for Star Wars, but eventually you can't eat dollars. And eventually you have to start selling them. And so when I was in Japan in 1985, the exchange rate was 240 yen to the dollar. What is it today? What has it been since about 1990? It's around 100 yen to the dollar. What does that mean in common sense terms? We borrowed money at 240 yen to the dollar, and we're paying it back at 100 yen to the dollar. So we are paying the Japanese back the $1 trillion we borrowed for Star Wars and to buy Toyotas in the 1980s at 40 cents on the dollar. Pretty good deal, huh? Now, who are we doing that to right now? China. Okay, China is manufacturing, I mean, that was in the paper this morning, okay, about Trump has not reduced the Chinese trade deficit. The Chinese will loan us money, so we'll buy their goods, and right now China has got $2 trillion approximately of US dollars. And they still haven't found out how to eat it, okay? So someday the Chinese are going to have to let their currency float. And we will pay them back on all those video recorders and cameras and everything else. We're going to pay them back at 20 cents on the dollar because they are resisting letting the dollar float. Why can we do this? The fundamental reason is the fundamental real good that the earth, the fungible commodity that everybody trades in, is called energy today. It used to be steel back in the 1950s. And it turns out when the U.S. controlled 75% of the world's steel economy, 50% by 1960, and U.S. Steel wanted to raise the price of steel 10%, President Kennedy said no, because it would have been worldwide inflation to have a 10% rise in the price of steel. And he stared them down and forced U.S. Steel to not raise prices in the early 60s. U.S. Steel will blame that decision of the president with their demise. But what happened by the 70s, Saudi Arabia and others learned, hey, we got something the world wants, and we're going to put an embargo on oil. And so somewhere between 60 and 75, energy became the new commodity that controls the world economy. And what is energy sold in? What do they price a barrel of oil in? Dollars. Because we are the country that controls the currency that energy is sold in, we can go and we are the gold standard. We are the dollar standard, okay? And so people can loan us money when we need it, and then they end up with too many dollars, and we pay them back at cents on the dollar. It's a great place to be, except unfortunately, in the last 10 years, some of the Europeans have been looking at this, and they're saying, we wish we were there and controlled things. And some people are trying to change the sale of energy to some other currency. So, because we control the price of the denomination of a barrel of oil, and if you go look at some constant, if people do some constant value things, it turns out the price of a barrel of oil it's got some blips, but it kind of been fairly constant. Back 150 years ago, it was a gold standard and stuff. But anyway, I've digressed quite a bit, but I've told you some common sense things. I actually think it wasn't the U.S. Navy in the 1980s. It turns out the U.S. Navy coined the term of total quality management and good manufacturing practices in some of their memos in the mid-'80s. Okay? I think the origins of that went back to the U.S. Navy Thresher disaster in 10th of April 1963. Anybody know what the Thresher was? It was the first, yes. It sank right off Cape Cod here, about 600 miles off Cape Cod. And how did it sink? It was super classified at the time. I lived in Virginia Beach, Virginia, the world's largest naval port in Norfolk and stuff. Half of my neighbors, were, one of my classmates' father was head of the brand new John F. Kennedy aircraft carrier. Okay, he was a captain, which meant he was one of the top officers in the U.S. Navy at the time. And the Navy was devastated. They were on their first controlled deep dive. And the ship had been built in Portsmouth Naval Shipyard up here in Portsmouth, New Hampshire, which was a Navy shipyard. And the controlled deep dive, there are various stories now. It's not as classified. They've declassified a lot of the stuff. They think it was a seawater piping valve, okay, where they brazed a steel pipe where the seawater came in to help cool the nuclear reactor, and it let go. It was like a 6-inch pipe. And all of a sudden you got a 6-inch hole and you're on a controlled deep dive. And then they tried to blow their ballast tanks. There's an interesting story. I mean, my Navy guys, when they have to take this course during the summer, I've heard the Thresher story 5 or 6 times. And you can go on Wikipedia and read about it. But it turns out they had a tender, a ship, right above because it was a controlled deep dive. And they could hear the men screaming on their sonar as they went up. They'd blown their ballast tanks, but because they had a freeze up in the valve when you expand gases, they clogged the valve and they didn't blow the tanks completely. So they started heading up to the surface, and then it was just too heavy and it sank and just collapsed in about 6,000 feet of water. So anyway, it was a big deal for the U.S. Navy, and Admiral Rickover and other people basically shut down all submarine production for about 3 years. And they instituted with a guy, W. Edwards Deming, who was one of the quality gurus who had taught statistics to the Japanese in the 1950s. And they brought him in, and they upgraded in a program called SubSafe. And this comes from the U.S. Nautilus, which is a blog of Navy people. The first loss of a nuclear-powered submarine devastated the naval community. The tragedy prompted the Navy to re-examine deep-diving submarine design, institute a quality assurance program known as SubSafe. And that's how the subs are still built today. You take my welding course, and I'll tell you how they made the joints. They redesigned the joints so that they would have a robust process that would be, if you know the term, Six Sigma, that would be high quality, although they didn't call it Six Sigma back then. Since that time, the Navy started instituting the SubSafe in the shipyards, and other people started picking it up. And there are various terms, one of which is lean manufacturing. This is, Wikipedia is the source. If you go look up lean manufacturing, this is a figure, and it's, sometimes people call this the house of quality. Quality at the top, stability with your foundation. You've heard of Kaizen, all these little terms, a lot of which come out of the Japanese lean manufacturing. Where did the term lean come from? Anybody know? Came out of this book right here. This is the machine that changed the world. Based on the Massachusetts Institute of Technology $5 million 5-year study on the future of the automobile. So Dan Roos was a professor of civil engineering. There's your civil. Hey. And Dan Roos had not been, he used to teach the introductory computer science course that I took as a freshman to learn how to program a mainframe computer with punch cards. And you guys don't even know what punch cards are? Anyway, so Dan used to teach that core course that had like a couple of hundred students in it. But then he got to the point where he knew most of the CEOs of most of the automotive companies in the world. And he sold them in the 1980s on $1 million a year program, which was a pretty good sized research program. And they were trying to figure out why Toyota was beating everybody's socks off in the marketplace. And they had quality, and General Motors and Ford and Chrysler turned out junk, okay? All the quality measures. People were quitting buying U.S. cars and buying Japanese. And so James Womack was the guy who really wrote the book and did most of the study, Dan Jones and Dan Roos. Well, Dan Roos was at that point basically a guy who he wanted the title of dean, okay? He didn't care if he was dean of engineering. He wanted the title of dean, okay, at MIT. And he didn't teach in classrooms anymore. And he had irritated some people. We had manufacturing before that. This is my sordid story of MIT and Big M manufacturing, which I'll have to finish the next time. But back when I was in the late 70s, I had gotten a $500,000 contract of my own as an assistant professor without tenure to study welding for the Navy. And I went to see, the Navy said, we'll give you $500,000, but you have to get some other people at MIT excited about welding. So I went over to see Nate Cook and Nam Su. Nate Cook was an expert on machining in mechanical engineering. Nam Su headed the lab for manufacturing and productivity. And he was a mortal enemy of Mert Fleming's, who had started the Materials Processing Center in 1980. And the one was the Lab for Manufacturing and Productivity, the other was Materials Processing Center. They both still exist. And they both hated each other and were trying to do the other one in. I had $500,000. Fleming's came to me and said, Tom, will you put your money through my center? That way we can show tremendous growth in research volume. And I said, okay, Mert. And then I wanted to get some people involved, so I went over to see a brand new assistant professor named Dave Hart in mechanical engineering, because Nate Cook told me to go see him. This new young guy that was looking for research money. I gave Dave Hart his first research contract out of my Navy money. Dave and I are still good friends today. Nam Su and Mert Fleming's just soon kill each other if they saw each other. Nam Su is now, he's retired, but he went off to be president of a university in Korea. Mert Fleming's got whitewashed by some things that happened with a woman who didn't get tenure, okay? And it's a long story. But anyway, and he never went any further, except that the administration loved him because he brought in a lot of endowed chairs. Kent Bowen in 1984 was asked to take over this new program to get industrial money for manufacturing. And he called me up in 1984, the night before I was leaving for Japan on my sabbatical, said, Tom, I've gotten a new job. I said, well, that's nice, Kent. Why are you telling me? He says, because he had been the director of Fleming's laboratory. Fleming's had stepped down and Bowen had taken over. He says, I've got to step down from that. I wanted to nominate you to take it over. I was a 34-year-old, just tenured professor, and anyway, I got to finish this up. I will finish it the next time. But I said, well, I guess I'm glad I'm going to Japan for a year, and I don't have to be the head of the Materials Processing Center and be in this fight with all these people, these big shots. He and Tom Magnani from the Sloan School started the Leaders for Manufacturing program in 1989 with about $35 million. And they gave, overnight, $35 million will buy you respectability at MIT. Manufacturing, which Dave Hart and I, we'd look at each other in 1989, we'd go to these meetings and say, these people don't know, they never knew how to spell manufacturing before there was $35 million. And now everybody was coming out of the woodwork saying, oh, I'm a manufacturing expert. And so all of a sudden, manufacturing got a big name at MIT. And it got a big name everywhere else, because when MIT says something's important, people listen, okay? And so we'll tell some more of this, but it gets worse and worse as these people, the powerful people at MIT, battle one another.